Hi and welcome. So this time around I have another project that is very similar to one I made in the past, where I'm making a fixture to allow them to weld this tiny little strip on a very specific distance from the edge, standing vertically. And it's for the laser welding company that I make fixtures for. And I learned a bunch of lessons last time, so I'm going to take some different approaches this time, and hopefully it'll make the part easier to make and make it fit better. Starting with the first problem, the hole size as spec'd on their drawing is 0.454 plus 5 minus 0, which means it can only be bigger than the pin size I made. So I figured if I made my pin 0.454, it's going to have slop no matter what I do, because these holes should be bigger. I'm not going to trust that this time because they were wrong. Secondly, the center hole is round. As you get to the outside, they become more and more slotted. And I'm not sure why. I don't know what this is exactly for, but they are slotted. So out here, these are actually sort of two holes offset from each other with a flat spot in the middle, because they are definitely not round. This one's round, then they get less and less round till you get the maximum slot out here. On the drawing, they spec from the center to the center of the slot, at least based on the drawing, and it turns out that it was actually the center, as if the pin or whatever was locating it was all the way to the inside on both sides. So when I made my pins fit center to center, I thought I'd have some side to side slop room. In reality, it was locked in. The test parts I had fit. When they got the production run, they did not fit, and it was a struggle, so we had to modify the pins. So we're going to work on that. And I'm going to use this piece of tooling plate to make the fixture like I did last time. However, this time I am going to machine it a little bit differently. But first, I think we need to do some metrology and see what these pin sizes actually are. First measurement this time, the hole is true to their drawing, meaning it's plus 2 thousandths. So instead of 0.454, this is 0.456, and it might even be 0.457. Yep, that's 0.457. The pin on the outside is 0.455, and you can see that it's slotted right here. So I'm going to measure edge to edge and compare that to their measurement. Maybe they fixed their drawings. That'd be nice. Now with the pin snugged all the way over to this side, I get 7.204 with calipers. Now that's not the most precision way to do this, but this is rough anyways. So let's just see how that compares. 7.204. Based on that measurement, I took half the pin diameter, so it's 7.204, the difference between these two pins. Half of this pin diameter, 0.455 divided by 2. Also subtract half this pin diameter, 0.457 divided by 2, which is 0.2285, and you get 6.748. The drawing says they should be 6.745 center to center. Guess what? Not center to center. That is all the way over biased again. So the drawing again is wrong, and what I can do is I can find the center of this guy and take that measurement and use that to put my hole size, and that'll give me side to side slop, because orientation, location of this side to side is not critical. Front to back is absolutely critical. So that's where we need the setup to be very accurate. All right, so I took measurements from the other side and came out with 6.772 from the far extreme over there with the pin all the way out, 6.748 all the way in. I subtracted those two, took half the difference and added to the small one, come up with 6.760 for the center of my hole, which is a full 15 thousandths difference than where they say the center of the hole is. Now I'm going to measure the other side, double check my measurements, and if they jive with this, then we're going to go with that value instead. So I did multiple measurements from side to side, pin here, pin there, measured outside, inside, took the difference, found the difference on both sides. It's about 29 thousandths, roughly 30 thousandths of a slot between edge to edge. I used a smaller pin just to make sure I go edge to edge. This is 0.454 as they said. First observation, the drawing says it's 0.745 from the center of this pin to the center of this slot. When this pin's all the way over, it's 0.748, so they were just completely wrong. I measured side to side, took the average of both. I also took the average of the center position of this slot on this side, average of the center position on the slot on this side, average those two together. It comes out with the center distance that I'm going to shoot for is 6.762 instead of 6.745, which is 17 thousandths. That is way off. If you had your pin exactly on, you'd have major problems trying to get them to fit. So this will give me a bunch of slop side to side, but nothing front to back, hopefully. Before I go any further, I was going to take a look at how accurate this material was cut. So this came straight from my material supplier, Industrial Metal Supply here in the Southland. This is tooling plate, and they cut it on a saw that uses a rotary blade from the top. It gets clamped down, and then the saw comes straight across and slices from the top. I wondered how accurate the cut is. So I'm looking over here, and I got 4.509 and change. Here's 4.510 and change. $4.508, 4.509. So looking at the surface finish, there are some little cutouts along the side here. It is absolutely amazing that this cut is accurate to within a couple thousandths across its length, both of them for that matter. Absolutely amazing. You wouldn't expect that. First order of business is just clean up these sides. They're not important. They're not going to be involved in any measurements. I'm going to find center side to side, but that's not a critical measurement because I've got a plus or minus ½ inch either side. So we're just going to clean these up, and for appearance sake, so that my fixture doesn't look like crap. Flipped it over and repeating the same process. And that's it. Last time I built a fence off the side of my mill, trammed it in, and used that fence to work on the part. Perfectly good solution. This time I've got a second Kurt vise since I got a deal on this one with the solid back. And I'm going to use both Kurt vices, but first I got to tram them in because I need to go from side to side. I need to make sure that this distance is identical side to side. So they've got to be trammed in. So first I stoned the whole surface to make sure I don't have any burrs before I put the vise down. And I'm going to go grab the second Kurt vise. I have two 5/8 locator pins on the bottom. That gets it very close, within like 10 or 20 thousandths of centered. And then we'll tram it in. Another use for the leather is underneath the Kurt vise here. When I set it on here, so I can stone the bottom and make sure that I don't ding the surface of this, because that's your reference surface. You can't afford to damage it. To set up the two vices and make them match, I've got this Brown and Sharp bar that I've got stuck between them. I wish it was a little longer. This is 12 inch. It would be nice to have like an 18 or 20 inch. That would be really nice, but they're super expensive. I've got one parallel on the back side of each vise. Both vices tightened on the part before I started, so cranked down nicely. I loosened both bolts on this bolt on this vise, and snugged this one. So it's levering around that one point. This big lever arm here is levering right around this guy. And then I ran the indicator down it. And I know you can't see right now, but we're better than ½ a thousandth over a foot. And I think that should be just perfect. Okay, we're right on the money. We're not even moving. Now let's see if I can gently snug and have it not shift like it did last time. Fortunately, the processes I'm going to be doing on this aren't going to take a ton of force, so I probably don't need to crank on this too much. I'm just going to be drilling 2 holes. So there's not going to be a lot of side forces trying to move the vise. So if they're snug, that should probably be adequate. All right, so we got the best side down and the side with the little divot up. And what we're going to do is we're going to take off like 10 thousandths, see if we can clean up this side. Then we're going to flip it 180, clean up the other side. Pretty light cut. We're going to lock off the knee. I thought there was going to be more vibration. It's actually not bad at all. I can't feel a whole lot. Just to check, I took a spring pass on the way back, and lo and behold, there's apparently some spring in the material because it's taken off tiny bits of material in several spots. Guess I'm glad I did. Gonna do the second side now. Come up 10 thousandths. And clean this side up. I also used the weld and flat holder and put the end mill all the way up so there's no chance for it to suck out like you do with the R8 collets. I didn't want to risk that because I want this dimension to be somewhat accurate. Here's a really interesting observation. So when I cut this width here doesn't matter at all. Could have been only 4 inches, it's 4.5. So I've been playing around trying to get these sides perfectly parallel with each other. Here's the interesting thing. Something must be like a burr or something, or a little tiny piece of dirt under one of these vices. So I've been trying to shim it up to fix the problem. It's actually worse than the saw cut from the supplier, which is really hilarious. And you can see down there, that's a folded over piece of zigzag paper. And what I did to make this easier on myself is I marked left, front, and right on the part so that I could come back and get it in the vices the same way each time. It actually doesn't need to be parallel. I just need one flat surface to reference off of. So this is now an experiment to learn something. Also, I noticed, interestingly enough, the DRO confirms it, that as the table extends off of one side of the mill, when it goes way off that side to get down here, it's twisting the knee, and the DRO's reading almost 1,000th change in height as the table goes way off the end there, which is kind of interesting. I always zero it before I start, and I can watch it progress. As the table goes more and more off, the weight is causing it to the knee to twist because of the weight of the table extending off the end. Took a couple tries to get everything right, but I'm within 1/1000th now. And the way I did that was I ended up quadrupling the zigzag paper just under the one corner here, and that got it right, almost right on the money. That was pretty impressive. It's like 1/1000th over 21 inches. That's not terrible. Using 2 vices means I need 4 parallels. And I measured the distance for my inexpensive parallels. They're Chinese made ones. And I have 1/4-inch ones and 1/8 inch ones. So I measured the 1/4-inch ones, and they were, say, 1.626, and the 1/8 inch ones were 1.628. They were 0.02 difference. So I can't really use them where I'm going to have my plate angled. So I have these angle blocks here, and they're matched sets. These two are matched, these two are matched. They're within a couple tenths of each other. So I'm going to use those to set the plate on so that I can ensure that it's parallel up and down. I mounted the plate in the 2 vices that I have being held parallel. They're sitting on the angle blocks, and I checked tram, and it's about 1/1000th from end to end. So that'll be acceptable. 1,000th would be acceptable. This is plus or minus 5/1000ths on position, so we're well within. Just measuring the, finding the center, and then I'm also going to find the absolute of that side, and I'm going to do it from the middle. That way I'll get my error minimized. All right, so now we just need to drill and ream 2 holes. Make things easier on myself, I think I'm going to do some hard turning. This is a hardened pin, 1/2 inch. Slightly oversized. I think it's 0.5005, and I've got this guy dialed in here. It's in a hex ER32 collet holder that you use for making like a bolt end in the mill, but it also works great in the 6-jaw chuck, and I got it aligned nicely, and my run out is in a couple tenths. That'll work. All right, so we're going to try and hard turn this guy. It's going to probably make a mess, and it's probably going to destroy these carbide inserts. I have one CBN insert, but I hate to use it because I need to read more before I use it. So I'm going to try this with carbide and see if I can get it to work. I'm hand feeding that just to get a feel for it. This is a pretty light cut. The pip is a real problem. It does not want to remove that. So the little pip, when I hit it, it aced my insert, and just like that. All right, let's see if we can take a longitudinal cut, 10 thousandths. Okay, quite a bit of deflection even with a 10 thousandths cut, but it did cut it. Not terrible. Okay. Knowing what the hole size on these things are, that they're all oversized, this should actually fit. Oh yeah, no problem. Oh yeah. Yeah, no problem at all. Okay, we don't need to worry about those couple tenths that it's over. It's 0.4545 right now. All right, so now we need to see if we can part this off. Now that is something I kind of think I'm going to have a serious problem with, but I'm going to try it anyways. Yeah, that ain't happening. Okay, we'll have to use a cutoff wheel to do it, but I've marked my location, so that should help. All right, we're going to take an abrasive cutoff wheel here, try and cut this guy off. I am not great with one of these. One of the tools I'm aiming to get eventually is a cutoff wheel for my surface grinder. Then I could cut parts like this guy off. Last step is to press these guys in. So I'm going to do that over on the arbor press. I can't easily show you that here because there's no room to set up a tripod over there. So you just have to wait till I come back. All right, let's see how we did. So here's the pins. This is the business end over here. So one of these guys sits right here. I've got side-to-side slop now, which I didn't have before, which is very good. And if I take this guy and set this here, see if I can miss the pins. Okay, supposed to be 90 thousandths from the edge here. So let's see how well we did. Okay, so I'm going to hold this guy flat. I'm going to dial this in. Looks like it's 92 thousandths. So instead of 90 thousandths, we're about 2 thousandths over, but I don't trust their stampings. Let's see if another one we get the same measurement. This should have been tight, by the way, but because they're so sloppy in their holes, I mean, it's sheet metal, so I can't blame them for being sloppy, but then they shouldn't spec the part to the incredible accuracy they spec'd it to. Okay, let's see. Same thing. A little over 90 thousandths. Should be good to go. That's it. Thanks for watching. Hope you find it useful. Hope to see you next time.